Donald, if you'd like to take it away.
Yep, will do. Thank you, Ben. All right, so the problem that we've been facing is that some of our models take a long time to run, in excess of 13 to 54 hours, depending on the model. And in addition to that, if we want to run any sensitivity simulations, then that just tacks on an additional several hours to the analysis. So that was the problem that we proposed to DCS a couple months back. Just a little bit of information on the model itself that's taking so long, just to give you an idea of what's involved with it. It is a traditional model with feature points and DCS points, so there are no mechanical or compliant moves in this one. There's only 10 parts, so not necessarily complex in its parts, or tolerances, in fact, only 54 tolerances. Where it starts to get a little more complicated is in some of the surfaces. There's over 270 involved, and as you can see, some of the images on the right, there are gear teeth involved that we have to worry about meshing, as well as just other complicated curves. So involved with that are about 295 measures that have to be analyzed to get the study completed, of which 67 are feature measures. So that starts to eat up simulation time there. In addition, we are configuring the parts in 5 different build positions. So that adds on some complexity, as well as the moves. It takes about 91 moves to build in all those different positions, and of which about a third of those are iteration moves. So anybody who's used the iteration moves, that slows you down considerably, especially when you have feature measures involved, of which we have 24 of our 32 iteration moves using feature measures. So just to make things a little bit worse, we have some nested iteration moves as well. So the amount of logic that goes into some of these models is really what's slowing it down, coupled with the amount of feature measures that we need. Okay, some additional challenges with the current situation. We would actually like to use even more dense meshes, as shown in the picture on the right here. That would be what we have to live with in order to speed up some of the simulations. We'll be creating a less dense mesh, where we prefer over on the right, where you can get a more dense mesh to get a more accurate model. So we would actually like to make things even more complicated, I guess. Additionally, we'd like to add more iteration moves so that we don't have to make assumptions. We can mimic the actual physical real world better if we can add more iteration moves in. So all these things, of course, are going to increase simulation time. Some more challenges. We've typically been only running about 2,000 simulation runs, and we'd ideally like to get that up around 5,000 just for our own internal practices. Additionally, it would be really nice to simultaneously be able to experiment, either design of experiments or testing simple single factors, where we could run multiple models simultaneously, get results back, analyze it, and be able to help us optimize faster that way. And then, to make matters a little more worse, we would like to have our own license available for modeling and not have to be tied up for 54 hours in the simulation. So those are really all the problems that we came to DCS with, and as you'll see today, they've provided really solutions that address each of these. So I'm going to go ahead and turn it back over to Eric, I believe now, and he will start to tell you about them.